Welcome to Softwaring's channel. I'm Lordman. In this video, I will show you how can you analyze truss by using ANSYS software, especially on the mechanical APDL. So in order to do that, you have to know some properties like geometrical and materials, even the loading condition. Beyond that, you have to select or have to know which type of element you have to use and the analysis type you have to follow. So in order to that, you have to get all the required parameters like the joint displacement and the reaction forces. So in order to do that, you have to know what's going on the black box of the ANSYS. So in order to do that, you have to know, or you have to put that manually, how can you calculate the displacement and the reaction force, so any truss structure. Anyways, in this video I will show you how can do this step by step. Keep watching. So once you have to open your ANSYS software, it display like this. So to start to use, you have to set your preference. So this is an structural analysis, so you have to select structural discipline. Then you have to get in on preprocessor. So in preprocessor, you have to select, or you have to add your element type. So in this case, our element type is link 180. So this is our element type. After that, we have to put our real constant. So in such case, the real constant is an area. So it has its own a unit area. Now, let us define our material property. So our material properties are anisotropy, so it is modulus of elasticity 2 is the power of 10, and Poisson ratio is not given, so we can put 0 or leave as a default. So real constant is not added in such case, so this is ANSYS 19. So in such case, we have to put the real constant in the sectioning part of the preprocessor. So from the sectioning, there is link, so we can add. So let us call it number 1, and the name of the area, let us say it is an area, and the amount of area is a unit area, 1 centimeter squared is this area of this link. So let's say okay, so we just put the area of the link. After that, what we have to do is just create the geometry by key pointers. So let us create key pointers in active coordinate system. So let's assume the first key point is at the origin, the second one is at those coordinates, the third one will be and similarly the fourth one will be 200 per 100. So where we create 4 different key pointers, so we can create the element. So we are dealing with link. Okay, let us delete all those key points, and let us do by using nodes. So let us delete all those key pointers, select P all. So we delete all the key pointers we have created. Let us create node. My gosh. Let us create nodes here on active coordinate system. So let us assign the first one as the origin. The second one will be 50 by 50. The third one will be Similarly, the fourth one will be 200 by 100. Yeah, you just create, we have created 4 different nodes. After that we can create element by using nodes, so we can create element by using through nodes. So let us create the elements. Yeah, once we create those elements, what we have to do is just apply the loading condition. So the loading condition in this case is we have to define the load structural displacement. So at node 1 it's fixed. At node 1 it's fixed. Similarly, at node 2 is fixed. At node 2 it is fixed. Yeah, after that we have to apply the force at this, the force node, its magnitude is 1000, and the y direction, its magnitude is 1000. Yeah, so we have finished the loading condition. So after applying all the load, we have to get in the solution stage. Since this load, I have a single load and a single load step, so we have to solve the current loading steps. So the solution is done. This is new news, this is good news. So once we finish the solution stage, we have to get all the required parameters from the general post-processing stage. So from the general post-processing stage, for example, if we want to enlist form, the first question was the reaction solution. So if you want to all items, for example, all items, we can get in this form. So the node at 1 and at node 3, the reaction forces will be this much in the x and y direction. Similarly, if you want to get the deformation, so joint displacement, so nodal solution from this DOF solution, if you want to in the x or in a vector sum form, you can see the displacement at all 4 nodes. At all 4 nodes we can get all the displacement. Beyond that, you can extract anything you want from this post-processing stage. So but the problem size to know the reaction solution and the nodal displacement. So that's enough for this tutorial. So I hope you guys is interesting for you. So if you want to get more updates, please do not forget subscribing my channel. Thanks for watching. Thanks.